Hello, science fans. Ever wonder how clean water gets to your faucet? It's not magic, it's pumps. Pumps are the heart of water treatment plants, pushing water from rivers and lakes into treatment facilities and then to your home. Without pumps, the whole system would stop. No water, no life. Imagine a giant river far from your house. Pumps move that raw water, full of dirt and germs, into the plant for cleaning. They work non-stop, providing the muscle to move massive amounts of water. At its core, a pump is a device that moves fluids using mechanical action, powered by an electric motor. This energy turns into pressure, pushing water through pipes, up hills, and into tanks. Think of it like a super-powered straw, moving water on a huge scale. Pumps are involved in every stage, pulling water in, mixing chemicals, pushing water through filters, and handling waste. They're the unsung heroes, making sure our water is safe to drink. Understanding pumps is the first step to appreciating the engineering behind clean water. Next time you turn on the tap, remember the powerful machines working behind the scenes. Let's see how they do it. Let's follow the water's journey through the plant. First, intake pumps pull raw water from rivers or lakes into the facility, handling everything from leaves to fish. Next, dosing pumps add precise amounts of chemicals to clump dirt together. These metering pumps ensure just the right dose, no waste, no mistakes. After clumping, water moves to settling tanks, then filtration, where pumps push it through sand and charcoal to remove tiny particles. Filters get clogged, so backwash pumps reverse the flow, cleaning out debris. Once filtered and disinfected, high-service pumps pressurize the clean water, sending it through underground pipes to homes and businesses. These distribution pumps must be powerful enough to reach tall buildings and distant neighborhoods. Every stage relies on pumps, moving, cleaning, and delivering water. Without them, the system grinds to a halt. Pumps keep water flowing, clean, and ready for you. That's the magic of engineering in action. Let's meet the different types of pumps that make it all possible. Not all pumps are created equal. Each has a special job. Centrifugal pumps are the workhorses, spinning water outward to move huge volumes efficiently. Submersible pumps operate underwater, perfect for deep wells or handling wastewater. Metering pumps or dosing pumps deliver precise amounts of chemicals. Think of them as the plant's syringes. These ensure just the right amount of disinfectant is added, keeping water safe and costs down. Progressive cavity pumps handle thick sludge using a corkscrew rotor to move solids without clogging. Each pump is chosen for its unique strengths, from moving clean water to managing waste. The right pump keeps the plant running smoothly and efficiently. It's all about matching the tool to the task. Now, let's see how the most common pump actually works. Get ready for some science in motion. Centrifugal pumps are the backbone of water treatment. Here's how they work. Inside, a spinning impeller acts like a fast merry-go-round, flinging water outward. Water enters at the center, the eye of the impeller, and is thrown to the edges by centrifugal force. The snail-shaped casing, or volute, slows the water down, converting speed into pressure. This high-pressure water is then pushed out through the pipes, ready for the next stage. By adjusting the motor speed, engineers control how much water moves and at what pressure. It's a simple, elegant process, spinning energy into water flow. That's why centrifugal pumps are everywhere in water treatment. They're reliable, efficient, and easy to control. Science and engineering, working together to deliver clean water. But how do engineers pick the right pump for each job? Picking the right pump is a science in itself. Engineers consider flow rate, pressure, and the type of fluid, clean water, gritty sludge, or corrosive chemicals. The wrong pump wastes energy or breaks down. The right one runs efficiently and lasts. Material matters too. Pumps handling chemicals need special alloys or plastics. Energy use is huge, so variable frequency drives, VFDs. Let pumps run only as fast as needed, saving power and money. Real-world example. Singapore's Tuas Water Reclamation Plant uses massive centrifugal pumps for intake, smaller ones for moving water between stages, and progressive cavity pumps for sludge. Each pump is chosen for its specific job, creating a reliable, efficient system. It's a symphony of machines, all working for one goal: clean water. Smart engineering keeps the system running and the water flowing. Next time you drink a glass of water, remember the pumps that made it possible. That's the power of engineering in action. Thanks for watching.